Welcome to the deep dive. We've spent time looking at, the building blocks of great businesses, mindset, ideas, all that good stuff.
Right.
Today, we're jumping into something really cutting edge, a field that feels like it's just about to explode. Artificial life.
Yeah, absolutely. We've sort of touched on this before, looking at future tech and innovation, which is, crucial for entrepreneurs, and artificial life. It holds such radical potential. So today, we're really focusing in making it the main event.
Exactly. So think of this as us pulling together threads from those earlier chats, creating a focused look just for you. Our mission today, pretty straightforward, actually.
Okay.
We want to get a handle on the science behind it all, look at the business angles, healthcare, agriculture, energy, the environment, you name it, and really importantly, think through the bigger questions, the ethical stuff.
Makes sense. So maybe the best place to start is the obvious question. What is artificial life, actually? It sounds a bit sci-fi, maybe robots or something?
Yeah, that's what springs to mind, isn't it? But the reality right now is maybe more biological.
It is, yeah. It's less about mechanical robots and more about creating biological things using, well, non-natural methods.
Okay, so unpack that. How is it different from, life as we normally think about it? What's the key distinction?
The big difference is the origin story, really. Normal life evolves naturally, reproduces using existing biological parts.
Right.
Artificial life, that's something we design and build. We use tools from fields like synthetic biology, genetic engineering, bioengineering.
Wow.
We're talking about designing totally new biological systems, or maybe taking existing ones and giving them a major overhaul. So creating things like synthetic organisms, or maybe cells engineered in the lab for a specific job.
And why is this getting so much attention, especially for business folks? What's the potential payoff?
Oh, the potential is just huge, really, across the board. I mean, think about medicine. Designing tiny organisms to make drugs much more cheaply or efficiently. Or in farming engineering crops that are way tougher against diseases. Or for the planet, maybe biological bugs that clean up pollution or generate green energy. The list goes on.
That definitely covers a lot of ground, which, makes you wonder how they're actually doing this. It sounds incredibly complex.
Well, yeah, it is complex. A really big piece of the puzzle is synthetic biology.
Okay.
What's really cool here is the idea of designing and literally building new biological parts or devices or whole systems, or, like I said, redesigning existing ones for a purpose.
So building with biology.
Kind of, yeah. And a key part of that is creating artificial DNA. So genetic code that's designed on a computer and then synthesized, made chemically, in a lab.
Right, not inherited.
Exactly, not inherited. And this custom DNA can then be put into cells, basically reprogramming them to do new things we want them to do.
Artificial DNA. That just sounds wild. How stable is that? Can they make, whole complex instruction sets?
That's a really good question. I mean, building huge, perfectly working artificial genomes, that's still a massive challenge.
But the progress has been amazing. They can synthesize longer and longer strands of DNA now, and making it stable is a huge focus. They're using different chemical tricks and design ideas.
Okay.
Right now, they can make pretty big chunks, and often they'll slot these into an existing organism where the cell's own repair systems can help keep it going.
That's just mind-blowing. And we've also heard a lot about genetic engineering, especially CRISPR. How does that fit in? Is it the same thing?
It's related, but different. Equally powerful, though. Genetic engineering, particularly CRISPR, isn't so much about building from scratch. It's more about making super precise edits to the DNA that's already there in a living thing.
Oh, okay.
Think of CRISPR as tiny molecular scissors, really precise ones. They can find a specific spot in the DNA, make a cut, and then scientists can add, remove, or change the genetic information right there.
So less like writing a whole new book, more like editing a specific sentence. That's a great analogy, yeah. So you can create new life forms by tweaking the existing code, like engineering bacteria to pump out a specific drug, or changing a crop gene to make it drought-resistant. Synthetic biology writes new programs. Genetic engineering edits existing ones with amazing precision.
Got it. So we're not just creating new recipes, we're also perfecting old ones with these tools.
Yeah.
And what about artificial cells? You mentioned those too.
Absolutely. That's another really exciting frontier, trying to build things that act like cells from the ground up, using basic biological parts, but not necessarily starting with an existing cell.
How does that even work?
Well, scientists are using things like lipids, fatty molecules to create membranes, like the skin of a cell. Then they try to put genetic material and proteins inside.
Uh-huh.
The goal is to create these minimal systems that can do basic cell stuff like metabolism, maybe even copy themselves. And looking further out, some researchers have this really ambitious goal. Not just tweaking life or making simple cell mimics, but building entirely new organisms. Organisms designed for functions we've never seen in nature, maybe something hyper-efficient at making biofuels or breaking down plastic waste or cleaning up specific environmental toxins.
Wow. Organisms designed purely for a job. Okay, this is where it gets really interesting for potential businesses, right? Let's dive into some of those applications. Healthcare and medicine, you mentioned drug production.
Yes, huge potential there. Imagine, say, engineering yeast or bacteria to produce complex pharmaceuticals like insulin, maybe much cheaper and greener than current methods. That could make vital medicines accessible to so many more people.
That alone would be massive.
Totally. Or think about designing microbes that could live inside your body like tiny factories, making medicine right where it's needed, when it's needed.
Personalized drug delivery almost.
Exactly. It could change everything about how we deliver therapies. And it links into personalized medicine, too, tailoring treatments based on someone's specific genetic code. And then there's the potential for treating genetic diseases directly by correcting the faulty genes inside cells. That's truly transformative stuff.
It really is. Okay, what about food? Agriculture came up too. We already have GMO crops resistant to pests and things. What's the next level with artificial life?
Yeah, we could go much further. Think about lab-grown meat, for example. Cultivating meat from cells in a lab setting.
Right, I've heard about that.
It could offer a way to produce protein that's, potentially much more sustainable and maybe more ethical than traditional livestock farming, especially with growing global demand. And beyond that, maybe designing entirely new synthetic proteins. Proteins built molecule by molecule to be super nutritious or have specific properties that could be vital for food security. Or engineering crops to grow in really tough conditions like deserts or to produce extra vitamins directly.
Okay, so healthier people, more sustainable food. What about the planet itself? Environmental sustainability, you mentioned cleanup crews?
Precisely. That's a really promising area. Imagine engineering microbes specifically designed to gobble up oil spills much faster than nature can.
That would be incredible after a disaster.
Or designing organisms that can actively pull CO2 out of the atmosphere, a biological approach to climate change mitigation.
Wow. Carbon capture, but alive.
Sort of, yeah. And synthetic biology could help create genuinely sustainable resources. Engineering organisms to churn out advanced biofuels or biodegradable plastics, cutting our dependence on fossil fuels and polluting materials, maybe microbes that turn farm waste into energy.
So these tiny engineered things could become our partners in cleaning up our mess. And finally, energy. How does artificial life play into generating power?
Well, it taps into the natural power of microbes, their metabolism, but engineers it to be better for energy production. Scientists are working on microbes that can turn sunlight or waste or algae into biofuels much more efficiently.
Cleaner fuels.
Exactly. Cleaner, more sustainable alternatives. And beyond just making fuel, the research could lead to entirely new biological ways of doing things that are just fundamentally more energy efficient.
It's almost overwhelming, the sheer scope of it all. Looking ahead then, what's the business landscape look like?
Yeah.
Sounds like fertile ground for entrepreneurs.
Oh, absolutely. This is definitely a frontier area. We're probably going to see whole new industries pop up, businesses focused on bio-based products, engineered solutions for farming or medicine, maybe services for designing and managing these artificial life systems.
So opportunities across different skill sets.
For sure. People with backgrounds in biology, yes, but also engineering, computer science, even business strategy. They could all find a place at the forefront here.
And is it just startups or are the big players getting involved? What about investment?
No, it's definitely not just startups anymore. Venture capitalists are paying close attention, putting significant money in because they see the disruptive potential. Established companies, big pharma, agriculture giants, energy firms, they're exploring it too, looking for applications, forming partnerships. And governments are getting involved, recognizing the strategic importance, funding research.
So lots of momentum building.
Yeah, all that interest coming together. It suggests things are really going to accelerate in terms of getting these technologies out of the lab and into the market.
So, okay, bringing it back to our listener, someone navigating business and innovation. Why should they really be paying attention to artificial life right now?
Because fundamentally, it has the power to reshape the core industries that touch every part of our lives: our health, our food, our energy, our environment.
Right.
It offers potential solutions to some massive global problems: climate change, disease, resource scarcity. But it also creates this huge space for innovation, for new value creation, for businesses that tackle future needs.
So staying informed is key.
Absolutely. Understanding where this field is going, the breakthroughs, the challenges, that's going to be crucial for any entrepreneur or business leader who wants to stay ahead of the curve.
Well, this has been really eye-opening, a true deep dive into artificial life. Let's just quickly recap the big things. We've seen this incredible power of synthetic biology, genetic engineering, tools to actually engineer life. And we've touched on this huge range of potential uses: medicine, food, environment, energy. It's staggering.
It really is. The ability to design and manipulate life at this level, it's profound. And it's moving fast. So keeping up with the science and the business side is going to be essential for anyone looking towards the next big wave of innovation.
And that leads us perfectly into our final thought for you today. As you go about your day, just think for a moment. Where might these advances in artificial life intersect with your world, your industry, your expertise, your business ideas?
Yeah, what problems could be solved in a totally new way?
Exactly. What new products or services might become possible? Could a new venture emerge? It's a field that really pushes you to think creatively, to imagine how we can build with biology.
It's about balancing that huge potential with the responsibility that comes with it, too.
A critical point. So keep exploring, stay curious. This incredible field might just spark your next big idea. Thanks for diving deep with us today.